Commercial passenger planes are engineered to operate within certain speed limits due to a variety of factors. These limits are set to ensure the safety and efficiency of the aircraft, as well as to minimize costs and environmental impact. Although it may seem desirable to increase the speed of passenger planes, there are many technical, economic, and logistical challenges that make it difficult to do so. In this sense, the current speed of commercial passenger planes is the result of a careful balancing act between various considerations, including safety, comfort, fuel efficiency, and cost-effectiveness. In this context, it is worth exploring some of the key factors that limit the speed of commercial passenger planes, as well as some of the potential benefits and drawbacks of flying faster. Can airplanes fly faster? Airplanes can fly faster than their current maximum speed limits. However, there are several factors that limit the speed at which commercial passenger planes can operate. One of the main factors is the design and engineering of the aircraft itself. Commercial passenger planes are built to be aerodynamically efficient and safe, but increasing their speed beyond certain limits would require significant changes to the design and materials used. These changes would increase the weight and cost of the aircraft, making it less fuel efficient and more expensive to operate. Another factor that limits the speed of commercial passenger planes is the availability of suitable engines. Jet engines, which are used to power most commercial passenger planes, have a maximum operating speed limit. Increasing the speed beyond this limit would require the development of new, more powerful engines, which would be expensive and time-consuming to design and produce. Other factors that limit the speed of commercial passenger planes include air traffic control regulations, fuel efficiency considerations, and the potential impact on the environment. Flying faster could require more fuel, increasing the cost of the flight and the carbon footprint of the aircraft. Flying slower to save fuel. Flying slower is a common technique used by airlines to save fuel and reduce costs. This technique, known as slow flying or fuel-efficient flying, involves operating the aircraft at a reduced speed, usually a few knots below the maximum cruising speed. The primary benefit of flying slower is that it reduces the amount of fuel that the aircraft consumes. When flying at high speeds, the aircraft encounters more air resistance, which requires more fuel to maintain the speed. By flying slower, the aircraft can reduce its fuel consumption and save money on fuel costs. Flying slower can also help reduce the environmental impact of air travel by reducing the amount of carbon emissions produced by the aircraft. This is important because the aviation industry is a significant contributor to global carbon emissions. Overall, while flying slower may not be the most glamorous technique for saving fuel, it is an effective and commonly used method that can help airlines reduce their operating costs and their impact on the environment. Technical limitations. There are several technical limitations that constrain the speed at which commercial passenger planes can operate. Some of these limitations include: 1. Aerodynamics. The design and shape of the aircraft must be aerodynamically efficient to minimize air resistance and drag. As planes fly faster, they encounter more air resistance, which requires more power and fuel to maintain speed. Therefore, the design of the plane needs to be optimized to achieve the maximum speed without compromising safety and efficiency. 2. Engine power. The engines of commercial passenger planes have a maximum operating speed limit. The current engines used in commercial passenger planes are designed to operate efficiently at a certain speed range. If planes were to fly faster than this range, it would require the development of new, more powerful engines, which would be expensive and time-consuming. 3. Structural integrity. As planes fly faster, they generate more heat due to air friction. This can cause structural integrity issues if the plane is not designed to handle the increased stress and temperature. Therefore, the design of the plane must take into consideration the effects of high-speed flight on the materials used. 4. Safety. Safety is the most important factor in aviation, and flying faster increases the risks associated with flying. Therefore, aircraft must be designed to ensure safety at high speeds. This requires additional safety measures, such as increased maintenance and inspection schedules, to ensure the aircraft is safe to fly at high speeds. Comfort disincentivizes speed. It is true that passenger comfort is one of the factors that disincentivizes increasing the speed of commercial passenger planes. At high speeds, passengers can experience discomfort due to increased turbulence, noise, and vibration. Additionally, Higher speeds can increase the stress on the aircraft, which can lead to more maintenance issues and potential safety concerns. In order to maintain passenger comfort and safety, airlines generally prioritize smooth and steady flights over faster ones. This is why most commercial passenger planes operate at a speed range that maximizes fuel efficiency and minimizes turbulence, even if it means sacrificing some speed. While there may be some incentives to increase the speed of commercial passenger planes, airlines must balance these incentives against the need to maintain passenger comfort and safety. This means that any attempts to increase speed must be carefully evaluated to ensure that they do not compromise the overall quality of the passenger experience or the safety of the aircraft. Challenges of supersonic flights. Supersonic flights, which travel faster than the speed of sound, pose several challenges that make them difficult to operate on a commercial scale. Some of these challenges include: 1. Noise pollution. Supersonic flights produce a loud sonic boom that can be heard on the ground. This noise can cause disturbance to people and animals, and therefore there are strict regulations on supersonic flights over land. This limits the potential flight paths and destinations for supersonic planes. 2. Engineering. Supersonic flight requires advanced engineering and materials technology to ensure the aircraft can withstand the high speeds and temperatures associated with supersonic travel. This technology can be expensive to develop and maintain. 3. Fuel efficiency. Supersonic planes require a significant amount of fuel to maintain high speeds. This can make supersonic flights less fuel efficient than subsonic flights, which can be expensive and increase the carbon footprint of the aircraft. Commercial passenger planes are optimized for a speed range that maximizes fuel efficiency, minimizes turbulence, and ensures passenger comfort and safety. Technical limitations, passenger comfort, and supersonic flights pose challenges.